Hello, my name is Michael Goddard, and I'd like to introduce to you my project, Coding Bootcamp, an educational tool for new programming students. Due to the IT revolution, programming skills are in incredibly high demand. Companies the world over are in search of skilled software engineers. The demand for software developers is so high that US News & World Report listed software developer as the #1 job in America for 2014. Software development received high marks for its high median salary, low unemployment rate, and the nearly 140,000 jobs that are expected to be created within the next 10 years. In order to meet this high demand for skilled software engineers, we need to reform computer science education. Studies have shown that between 30 and 60% of all introductory programming students will fail in their first class to form any kind of comprehensive understanding of the flow of programming languages. These students will also fail to form an understanding of the building blocks of programming languages, including variables, arrays, loops, conditionals, scope, and functions. The root cause of this problem is due to the frustration that new students often face when trying to learn to program. These students often get highly frustrated with the syntax and semantics of these languages and spend more time fighting the compiler than actually thinking logically about what their program is supposed to be doing. In order to solve this problem, we need to give the student practice in the critical thinking skills that undergird computer science. This is where my project, Coding Bootcamp, steps in. At its core, Coding Bootcamp is the random and dynamic generation of programming logic problems that a new student can use to practice. These problems do not actually ask the student to write their own code, but instead give the student a complete program and simply ask them to follow the execution of that program or to make slight modifications. In this way, we can take the frustration out of practicing programming and allow the students to hone their skills in a safe and controlled environment. Here is an example problem generated by my project. If you're familiar with programming, you can see here this is a very simple for loop. All this question does is ask the student to follow the execution of the program and find out what it returns. If the student is familiar with for loops, they should have no problem solving this problem. But if not, then they should go back to their educational material or their teacher. You will notice in this problem that the pseudocode-like language that I have custom built for this project. This language that is used here in this problem is easy to learn and easy to use for all students, no matter what language their primary instruction is in. Now let's take a look of the project working in action on the web application. Here I am on the web application logged in as a student. Here, students can access their classes and complete the practice exercises. I'm going to go ahead and begin a class, and so we can see the problem generation live. Here is the generated problem that has been given to us. This problem was randomly generated on the fly right as we requested it. This problem is a more advanced problem after the student has shown mastery of both conditionals and for loops. This is called a nesting problem. This tests the student's understanding of how nested conditionals and loops operate. Similar to the other problem I showed you, this question asks the student to follow the execution of the program and find what is returned. I'm going to go ahead and put in the correct answer, A. With the correct answer, the project will generate a new question for us to complete, which we'll go back to later. As the problems generated by Coding Bootcamp are all coding problems, the core challenge of my project has been code generation. To accomplish this, I used a tree-like nested hierarchy system where each level of the hierarchy is responsible for creating and managing the level beneath it. The hierarchy system is what allows for the random and dynamic problem generation. The generation is random enough such that an infinite amount of problems can be generated for the student to complete, but it is dynamic enough so that the problems generated are commensurate to the student's ability level. The difficulty of the problems has to be carefully managed. The student will see slightly easier or slightly more difficult problems when they return either correct or incorrect answer. We can see this difficulty modification when you return to the web application. Here is the question we previously completed. As we've got the correct answer, we can move on to the next problem. As you can see, this problem is slightly more difficult, as there are now 3 levels of nesting instead of 2. In this problem, you can also see the modular randomization that occurs with the problem generation. Each level of the nesting has been randomly generated one at a time in turn. This type of modular randomization allows for a wide range of problems to be generated, but prevents difficulty from spiraling out of control too quickly. Students who complete the curriculum will have mastered the fundamentals of programming and will be well on their way to a successful computer science education and career. Thank you for listening to the introduction of Coding Bootcamp, and I invite you to try it for yourself.